Hello friends, today we start 9th standard science first lesson laws of motion. In this video, we have to study what is meant by motion, type of motion, distance and displacement and some problem. Before going to start this lesson, we recall some concept that we already studied in previous standard. So for this, we take some example. First, the flight of a bird. Second, leaves flying through air. Third, a stationary train. Four, a stone lying on a hill. Can you tell in which of the example you sense motion? How will we explain presence and absence of a motion? Now, first example, the flight of a bird. Now see here, bird is flying. It changes its position. Now, second example, leaves flying through air. Here also, leaf changes its place. Third example, a stationary train. Here, train does not changes its place. For example, a stone lying on a hill. Here also, stone does not change its place. Among these four examples, first, the flight of a bird, and second example, leaves flying through air. Here, objects are changing their position. That means they are moving. So we sense they are in motion. Third example, a stationary train, and fourth, a stone lying on a hill. Here, object does not change its place. So we sense they are not in motion. Now, motion. Moving objects are said to be objects in motion. In our day-to-day life, we see many moving objects. While waiting for a bus at a bus stop, other vehicles appear to be in a state of motion. On the other hand, when you are in motion yourself, a still object appears to be moving. For example, imagine you are traveling in a train and you see trees are moving backward in this way. But actually, train is in motion and trees are at rest, but we feel trees are moving backward. So we say that if an object is seen by an observer to change its place continuously, the object is said to be in motion. If an object is seen by an observer to change its place continuously, the object is said to be in motion. Here, trees changes its place continuously. So we can also say that the continuous displacement of an object is called motion. The continuous displacement of an object is called motion. Now here, trees are changing their position with respect to surrounding. So we can also say that if the position of an object is changing with respect to its surrounding, then it is said to be in motion. If the position of an object is changing with respect to its surrounding, then it is said to be in motion. Now consider some objects such as moving train, clock, table, flying bird and stone. Which of these are moving? Which are at rest? How did you decide whether an object is in motion or at rest? You might have noticed that the bird is not at the same place after some time, while the stone is at same place. On this basis, you have decided whether an object is at rest or in motion. Motion seems to be some kind of a change in the position of an object with a time, isn't it? Are the objects like clock or an electric fan moving from one place to other? No. Do you notice movement in any of their parts? The blades of a fan or clock, how are they moving? Is their movement similar to that of a train or a bird? To understand these differences, now we have to study some type of a motion. There are two main types of a motion. First, linear motion and second, non-linear motion. First, linear motion. An object which moves along a straight line, this type of motion is called linear motion. An object which moves along a straight line, this type of motion is called linear motion. For example, a train or a moving vehicle on a road or an aeroplane may travel in a straight line or in a same direction. The motion of a soldier in parade is linear motion. Also, the motion of a bullet is in a straight line is linear motion. Now second type, non-linear motion. The motion of an object which does not move in a straight line is called non-linear motion. The motion of an object that does not move in a straight line is called non-linear motion. There are four types of non-linear motion. First, oscillatory motion. Second, periodic motion. Third, circular motion. And fourth, random motion. First, oscillatory motion. The motion of a body that is oscillating, that is swinging back and forth, is called oscillatory motion. The motion of a body that is swinging back and forth is called oscillatory motion. For example, pendulum of a clock. Now second, periodic motion. The motion of an object which passes through a certain point again and again after a fixed period is called periodic motion. The motion of an object which passes through a certain point again and again after a fixed period is called periodic motion. For example, string of a guitar, drum, tabla are being played. Now third, circular motion. The motion of an object along a circular path is called circular motion. The motion of an object along a circular path is called circular motion. For example, the motion of a pointed mark on a blade of an electric fan or hands of a clock are the example of a circular motion. Now fourth, random motion. The motion that changes its direction and speed continuously is called random motion. The motion that changes its direction and speed continuously is called random motion. A butterfly constantly flits from one flower to another. There is no definite direction to its motion. The motion of a flash in a game of football, crawling baby, or a wandering animal are also examples of random motion. There are some more type of motion that we have to study in higher classes. Have you observed closely the motion of a ball along the ground? Here, the ball is rolling on the ground, rotating as well as moving forward along the ground. Thus, ball undergoes a linear motion as well as rotational motion. That means a moving object may not have only one type of a motion. That means the moving object may not have only one type of a motion. Can we think other example where the object undergo combination of different type of motion? Now it's time for think about it. Imagine you are traveling in a bus. Is a person sitting next to you in a motion? Of course, no. Then what do you take into consideration to decide if an object is moving or not? We take into consideration frame of reference or position of an object changes with the time. We say object is moving only when it changes its position with respect to time. But here person does not change his place. Even bus is traveling. That means here observer frame of reference is bus. There are situations where the motion is inferred through indirect evidences. For example, we infer the motion of air by observing the movement of a dust and movement of leaves and branches of trees. What causes the phenomenon of a sunrise, sunset and changing of the seasons? Is it due to the motion of earth? If it is true, why don't we directly pursue the motion of the earth? An object may appear to be moving for one person and stationary for some other. For the passengers in a moving bus, the roadside trees appear to be moving backward. A person standing on the roadside pursues the bus along with the passenger as moving. However, a passenger inside the bus sees his fellow passenger to be at rest. What do this observation indicates? This observation indicates most motion are complex. If we have to decide how much object travel, then new term comes, that is distance and displacement. Now let's try this. See figure A. Measure the distance between points A and B in different ways. Measure the distance between points A and B in different ways. Now second, now measure the distance along dotted line. Which distance is correct according to you and why? Now measure the distance along this dotted line. And which distance is correct and why? Now Think about it. Now see figure B. Here, Sheetal and Prashant house is given, Sangeeta house is given, and school. First, A. Sheetal first went to her friend Sangeeta house on her way to school. B. Prashant went straight from home to school. Both are walking with the same speed. Who will take less time to reach the school and why? In this example, here two parties given. First A. Sheetal first went to her friend Sangeeta house on her way to school. That means here Sheetal first went to Sangeeta house, so she chose path A. Then after that she went to school, so she chose path B. In this way. Now part B. Prashant went straight from home to school. Prashant went straight from home to school in this way. That means 1300 meter. And here one condition is given that both are walking with same speed. Here we have to find who will take less time to reach the school and why. That means we have to find who will first reach the school, and here we have to write down reason also. Now first we find Sheetal distance. So first distance traveled by Sheetal. Here Sheetal first choose path A, then after that path B. So path A plus path B is equal to 500 plus 1200 is equal to 1700 meter. Next, distance traveled by Prashant. He choose straight path. That means 1300 meter. Here one condition also given that Sheetal and Prashant both are walking with the same speed. From equation first, second, and with condition, we say that Prashant will take less time to reach the school. In this example, is there a difference between actual distance and distance travel? What is it? Yes, there is difference between actual distance and distance travel. That one is nothing but distance and displacement. So here we see difference between distance and displacement. Definition. Distance is the length of actual path traveled by an object in motion while going from one point to another. Distance is the length of actual path traveled by an object in motion while going from one point to another. But displacement is the minimum distance between the starting and finishing point. Here, A is the initial position of object and B is the final position of object. Now see here, distance is actual path traveled by an object from initial position to final position, but displacement is minimum distance traveled by an object in this way. Now, second, direction consideration. To calculate the distance, direction is not considered, but to calculate displacement, direction is into consideration. Third, quantity. Distance is a scalar quantity as it only depends upon magnitude and not direction. But displacement is vector quantity. It only depends upon magnitude and direction. Now fourth, route information. Distance gives the detailed route information that is followed while traveling from one point to another. Distance gives detailed route information that is followed while traveling from one point to another. But displacement refers to the shortest path. It does not give complete information. Now see here, initial position, this one that is final position. If path is in this way, then distance gives total route information. But we know that displacement means minimum distance traveled by an object. That means in this way, that means it does not give total complete information. Now fifth, possible values. Distance can only have a possible positive values and displacement can be positive, negative, even zero. Sixth formula, distance is equal to speed into time. Displacement is equal to velocity into time. Indication. Distance is not indicated with an arrow, but displacement is always indicated with an arrow. Denotation. Distance is always denoted by small d and displacement is always denoted by small s. 9. Measurement in non-straight path. Distance can be measured along a non-straight path, displacement can only be measured along a straight path. 10. Path dependent on path, that is, it changes according to path taken. But displacement does not depend upon path, and it only depends upon initial and final position of body. Now, use your brain power. Here we have to solve some problem. First, this figure A. First example, every morning Sorali walks around the edge of a circular field having a radius of 100 meters. If she starts from the point A and takes one round, how much distance has she walked and what is her displacement? Now, in this example, Sorali walks around this circular field. That means distance is along circumference of a circle. And here radius also given, that one is 100 meter. So to find distance, we have to find circumference of a circle. That means 2 pi r. Here r is 100 meter and pi. So we get distance is equal to 200 pi or 628 meter, because 200 into pi means 3.14, we get 628 meter. And here displacement. We know that displacement means final position minus initial position. So that one is nothing but 0. So we get final answer. She walked 628 meter distance and her displacement is 0 meter. Now second example. If a car starting from point P goes to the point Q and then returns to point P, how much distance has it traveled and what is its displacement? Now in this example, here car travels from point P to point Q, then again from Q to P. So here we have to find distance and displacement. Now first, distance. Distance means actual path traveled by an object. So here car travel from P to Q and Q to P. So distance is equal to from P to Q plus Q to P. Total distance traveled, that one is 360 plus 360 is equal to 720 meter. Now displacement. Displacement means minimum distance traveled by an object and displacement is a vector quantity. So here direction also concerned. So displacement is equal to from P to Q plus from Q to P. Here 360 plus minus 360 meter, because car travels back, that means opposite direction. So here sign is minus sign. So is equal to 0 meter. We get car has traveled 720 meter distance and its displacement is 0 meter. Now summary. In this video, we studied what is motion. We saw that motion is a change in the position of object with the time. The change in position can be determined through distance measurement. This allows us to know how fast or slow motion is. The movement of a snake on the ground, a butterfly flitting from flower to flower, a river flowing, an aeroplane flying, moon going around the earth, and blood flowing inside our body shows that there is a motion everywhere around us. Then we saw types of emotion. Next, displacement and distance and difference between distance and displacement. Then final, we see problems. To solve problem, we have to follow 3 steps. Step 1, what is given? Second step, what we have to find. And third, which formula we have to use. Now it's time for assignment. First, which of the following is true for displacement? A, it cannot be 0. B, its magnitude is greater than the distance traveled by object. Second question, an object has moved through distance. Can it have 0 displacement? If yes, support your answer with an example. Third question, Sachin travels 550 meters to north but then backtracks to south for 305 meters to pick up friend. What is Sachin's total displacement? 4. A bird sitting on a wire flies, circle around and come back to its perch. Explain the total distance it travels during its flight and its eventual displacement. You have to solve all these four questions.